This is Geometry, Unit 8, Day 15. This is the notes for the arc length and area of sectors. This is pretty much all a review of what we've been learning on previous days, so it's a mix of both the arc lengths and the sectors. So we're looking at two angles that are congruent. So over in our picture, we have our two angles the same, so they're both 80. To figure out the length of arc GF, we're going to use the arc length formula. So GF, arc GF, divided by, since arc is a length, it's the outside of the shape, it's part of the circumference, we know that the denominator would be the circumference. Equals the angle over 360. Well, that's what we don't know is the arc length. The radius is 7. The angle is 80 over 360. So we cross multiply. Arc GF equals 14 pi times 80 over 360. With your calculator, you would get that arc GF equals 9.77 meters. Next, we're going to look for the sector area in our circle. Well, that also has a central angle of 80. So we're looking for the sector. Since we're dealing with the area of the sector, I know that we're going to deal with the area of the circle. The angle over 360. There's your basic formula for a sector of a circle. So we're looking for the sector. The radius is 7, so it's pi 7 squared equals 80, because that is our central angle for this side, equals 360. So the sector is 7 squared is 49 times pi times 80, all over 360. So using our calculator, the sector is going to equal 3421. And those units are meters squared because it is an area value. For part C, we're looking for the arc EG. So EG, we could start with the proportion again and say that arc EG over the circumference equals 80 times 2, because that's the central angle, over 360. That would be an option. But notice that EG is twice as much as FG. So if we know 2 times FG, then we should know what EG equals. FG we found earlier is 9.77. So that's going to come out to be 19.54. Arc lengths would be just meters, not meters squared. Here we're looking for the measure of the arc. Recall that measure refers to the degree value, and the degree value of the arc is equal to that of the central angle. So in our formula, we have the measure of the arc is the angle. The arc itself we know is 2388. So I'm going to say AB as my arc, the arc length over the circumference. equals the angle over 360. We know the arc length is 2388. The radius is 12. Our angle is what we don't know, over 360. So we'll cross multiply. I'm just going to cross with the 360 because I want to keep the angle portion by itself. So 2388 times 360 over 144 pi, that equals our angle. So using our calculator, we would see that our angle is 114.02. Those are degrees for our angle. So our angle, you could say, was angle ACB. You could call it the measure of arc AB. That would be the arc of which it's the measure, and that's actually what they're asking for. Either way, the measure of the angle ACB would be the same idea. We're looking for the sector of ACB. So that's that shaded region. Well, if we're looking for the sector, which we don't know, over the area of the circle, pi 12 squared equals our angle, which is 114.02 over 360. We'll cross multiply to get the sector equal to 144 pi times 114.02 over 360. So the sector area is equal to 143.28, and those are inches squared. For our third example, we have our circle. We don't know what the radius is, but we know the central angle is 55, and we know the arc length is 1971 centimeters. We're looking for the radius of our circle. So to figure out our radius, we're going to take arc length, GH, over, that's an arc length, so it's 2 pi r, equals our angle over 360. And what we're going to solve for is our radius. We know the arc length is 1971 over 2 pi r. R is what we're looking for. That's the measure of our radius. The central angle is 55 over 360. Cross multiply. Now we have to cross multiply both ways for this because the radius is in the denominator. We need to bring it up on the same level. So 1971 times 360 equals 55 times 2 pi r. We have to divide by everything that isn't the r. So that's going to be the 55, the 2 pi. And we're going to do that to both sides. So our r value is going to be what our calculator punches out, which is 20.53, and those are centimeters because it's a length. To figure out the area of our sector, we have our sector area over the area of the whole circle. So that's pi r squared. Well, our r we just found out was 2052. The angle we know is 55 over 360. We'll cross multiply to figure out that the sector equals 55 times our pi r squared. Our pi r squared, the r squared, is 421.48 times the pi. You got to include the pi there. So that's the radius squared times pi divided by 360. So using our calculator, we notice that that was 202.30 centimeters. Last question down here. We're looking for the radius. We see our circle. It gives us the sector area, gives us a central angle. So how can we find the radius of a circle? This picture doesn't show it. How can we use the information they give us to lead us to the radius? Notice that A is a sector area. So I know that we're going to do sector over the area of the circle, which is pi r squared, equals the angle over 360. Well, we know the sector is 2379. We don't know what the area of the circle is. We don't know what the radius is. So that's going to be pi r squared. The angle is 80 over 360. So we'll have to cross multiply both directions and get 2379 times 360 to equal 80 times pi r squared. Now how are we going to get the pi? How are we going to actually get the r squared by itself? We would divide by 80, that will cross them out, and we can divide by the pi at the same time. You could divide them separately. So that's going to give us the radius squared as 3408. So we're going to take the square root of 3408 to figure out what just r is. So that gives us a 5.84, and our units are feet for our radius. Now we're supposed to figure out the length of the arc. It's like the pizza crust portion. So the length of the arc, we're going to say EF over the circumference. The circumference is 2 pi r. Notice the difference in the two formulas. 2 pi r calculates the distance all the way around it, kind of like the perimeter. And pi r squared, notice where the 2's at. The 2 is a square. A square unit is area. So sector, or area of a circle, always has square units, and the area of the circle has the radius squared. For length, you do circumference, and the 2 is in front. It's 2 times the radius, which is the diameter. 2 times the radius times pi. That's what's being asked for. Equals the angle over 360. So we don't know what that arc length is. We learned about the radius from the previous problem, 5.84. Angle is still 80 over 360. We can cross multiply. We only have to go the one direction because EF is by itself. So we have 2 times 584, which is 1168. Times pi times 80 divided by 360. So our EF, arc, the length of EF, is 8.15 feet. Be sure you can use your calculator to figure out your values. On the other side, we're looking for the perimeter of our region. To calculate the perimeter of the region, we have to go all the way around. We need to know the distance all the way around the shape. Notice that there are 3 sides that are all exactly the same. The fourth side is not part, the fourth side of our square here is not part of the perimeter. We do 3 sides and then we do this semicircle. It's half of a full circle. So we need to figure out what these 3 sides are first. Notice that the radius of our circle is 5. So if it's 5 on the way down, it's also 5 on the way up. So it's 10 for the full length of our square. 10 for one side and 10 for all the sides that are the same. So now we look at this and we recognize that we need to figure out our half the circumference. So to calculate half the circumference, we need to know 2 pi r. That's the full circumference. So we're going to take half of 2 pi r. So the perimeter equals 3 times 10 plus half of our circumference, 2 pi r, and r is 5. So the perimeter equals 30 plus half of 10 pi. Half of 10 pi is 5 pi. Now we can't add those together. That's not 35 pi. So we have to calculate what 5 pi is. So that's 5 times 3.14. We should use the pi button in our calculator and come up with about 1571. And when we add those together, we get 4571. And the units are millimeters. So that would be the total distance. That would be 10 plus 10 plus 10 and a half a semicircle. Half of the circle, which is a semicircle. This next figure, we're looking for the area of this shaded region. We know that we have an entire circle. The side of the box, which is made up of 2 full circles. These circles are congruent to each other. The full side of the box is made up of 2 of those circles, side by side. So the diameter would be, since it takes 2 circles to make up 8, I know that 1 circle has to be 4. If the 2 circles are congruent, then if the diameter is 4, I know the radius is 2. So notice 6 is the other side, but the circles are not making up the 6 whatsoever. The circle doesn't touch the top and the bottom, so it doesn't make 6 vertically. It only makes a total of 8 with 4 plus 4. So what we're going to do, we're going to look at rectangle area minus 2 times circle area. The rectangle area is 6 times 8. The circle area, there are 2 of them. To calculate area of a circle, we say pi r squared. So we have 48 minus 2 times 2 squared is 4, so we say 4 pi. 48 minus 8 pi. Now some people make the mistake here and say 48 minus 8 is 40. And that's not true because it's 8 pi. Let's use our calculator and figure out what 8 pi is. That's 2513. So now 48 minus 2513 is 2287. And those units are unknown, so we just say units and its area, so it's squared. The numbers don't have inches or centimeters next to them, so we just use units. For letter B, we're looking at a circle inside of another circle. We call those concentric circles. We have a radius of 9. That's the small circle. And we have a radius of 9 plus 3.5, which is 12.5. That's the bigger circle. So what we're going to do, we're going to say area of the big circle minus area of the small circle. So the area of the big circle is pi. The big radius is 12.5 squared, so pi times r squared, minus the small area, pi 9 squared. 12.5 squared is 490.87. That's 12.5 squared times pi minus 254.47. That would be your 81 pi. So subtract your two values and you get 236.4. And those are meters, because that's the unit that you're using, squared. That would be the area of this donut shape, just the outside, no center. Last question. We have this funny shape. What we're doing, we're putting salt down along the sidewalk. This is a fountain in the middle. So if we find out that one bag of salt covers 150 square feet, how many bags of the salt are we going to need to have? So we're going to need to figure out what the area of this shaded region is. So it's a funny shape. It's a rectangle and half of a circle. But it's really half of a donut because the middle of that circle isn't there. So we're going to break this into this big rectangle. And how I know we would go all the way over to the middle of the circle is because the 42.5 goes all the way over to the middle of that circle. So that's our rectangle. So what we're going to look at is this rectangle area, and we're going to have to subtract out this half of a circle. It's the full rectangle, not counting half the circle. So minus half of this small circle. Then we're going to have to add, because there's extra parts that we have to salt, we got to add this portion, which is a big circle, minus the middle part, very similar to what we did above in part B. So that's going to be half, because it's not all the way around, it's only on the right side. The big circle minus this small circle. So to do our calculations, the area of the rectangle is 30 times 42.5 minus half of the small circle. Well, if the diameter is 18, I know the area of the smaller white circle is pi r squared. The r is 9. The big circle has a diameter from the center out to its edge, which would be 15. So pi 15 squared. That full circle, the area is all the way through it. We don't want to consider this middle portion. So from that area of the big circle, we're going to subtract out this smaller circle, which was pi 9 squared. Using our calculator, we would take our 30 times 42.5 to come up with 1275. We're going to take half of pi times 81. That gives us 127.23. And we're going to add the pi times 225, because that's 15 squared, minus pi times 81. That is 452.39. Well, working from left to right, our 1275 minus 127.23 gives us 1,147.77, and half of our 452.39 is 226. 195 or 20 if you want to round to the nearest tenth. So it's that number plus 1,147.77 gives us 11,343.97. That's surprisingly large. Those would be feet squared. And we're going to take that 11,373.97 and divide that by the 150, because each bag covers 150. So this is coming out to be approximately 75.8 bags. So we need 76 bags. I'm a bit surprised it's that much. I see where my mistake came in. It wasn't 11,000. This is 1,000 plus 200. That is only 1,373 and 96 or 97. Okay, so over here this should be 1,300 divided by 150. That should give us 9.15, which is true. It's closer to 9, but 9 doesn't get the job done. 9 is still short. So we would actually need to get 10 bags. That's better. Okay, next we want to put a fence to keep rabbits away from the walkway. So we need a perimeter around that whole shape. So looking at our shape, we have 42.5, 42.5 plus the 30 plus another 42.5 plus our semicircle, just a half a semicircle. So half the circumference. So our formula for circumference is 2 pi r. And the r for the big circle is from the center out to the edge, which is 15. So we're going to take our 4250 plus the 30 plus the 4250, and we get 115. We're going to take half of 30 pi which is just 15 pi. Now you cannot add 115 and 15. Those aren't the same units because this has pi connected to it. So we need to see that 15 pi is actually 47.12, and add that to our 115. So we get 162.12 feet around the entire perimeter of our walkway.